Hi ladies and gentlemen, welcome back to another video in which I would be solving an SAT question on a candidate's request. So the question today is, so they have given us a function, the function f. It's a quadratic function, mind you guys. A quadratic means that it's going to be a parabola, either facing upwards or downwards. We're not sure yet, right? They have said that the function has zeros at x is equal to 1 and x is equal to 5. Now, what are the zeros of a quadratic function? They're simply the points at which the parabola, the graph, will intersect the x-axis. Just in case you guys forgot, they have given you the vertex 3 and -2. Now, the vertex, if you guys forgot in case, the vertex is the turning point. So let me give you a graphical visualization. So let's have a visualization with graph. So you have 3 and -2. Somewhere here you have your turning point, right? And then you have at x is equal to 1 and x is equal to 5. Okay, now at this stage we are not sure whether the parabola is like this or it is opening downwards, a sad face. We are not sure yet. Okay, I'm just giving you a graphical visualization yet. Okay, so far so good. Now, guys, as in every SAT test, the first and the main tip I'm giving you is to visualize the key points. Okay, the given information. The key information is, okay, you have a quadratic, you have zeros, and you are given with the vertex. What are they asking you to find? What is the y-intercept? We don't know the y-intercept. The y-intercept was the point at which the curve will intersect the y-axis. Okay, we don't know yet. It's a happy face or sad face. Now guys, I'm going to show you my first approach which I did, which is logical, but it did not work out. And then I'm going to show you what I did, just to show you guys that, hey, if something like this happens, no need to panic. As long as you're making sense, keep going. Find another way. So at first, what I did was, if you recall, the general form of a quadratic function is right, and then the completed square form is where your h and k will give you the vertex, right? So can I write this since I'm given the vertex, right? 3 and -2. So can I write it as a x minus 3 whole square and then -2, so plus k, so whatever the y value is, right? I can write it like this, right? What I tried to do was, I tried to find the value of a first by substituting the vertex. I hope you guys are understanding so far. If you guys have any question, you guys know my email. So finding a. Okay, so let's substitute 3 and -2. So that's your function, right? F is equal to a x minus 3 square minus 2. So let's substitute the value of f, which is -2, is equal to a. Let's substitute the x value, which is 3 minus 3 square minus 2. Now there was a problem here. This was cancelling out. I was left with this. I did not do anything wrong. It makes perfect sense, but I cannot find the value. So didn't work. What did I do? I did not panic. I took a deep breath. What I did then was no frustration, guys. This is just to show you that these situations can occur in the city naturally, so don't panic. Okay, there is another way. I'm given with the zeros, right? What was the general form? Ax squared plus bx plus c, correct? Now, I know that the two zeros, right, will give me two factors of x minus 1, x minus 5. Now guys, here's where people will make mistake. So I want to point this out. We are not done yet. No, we are not done. Why? Because let's say generally if a is greater than 1, x squared plus bx plus c, right? See, in order to write the equation only in factors, okay, this will give you a as 1, right? When you expand it, the coefficient of x squared will be 1, right? What if it's not 1? We don't know, right? We don't know. Let's say if it is greater than 1, so this would be a x squared plus b over a x plus c over a. Okay, I have not changed anything. I just changed the form. I took a as the common just to show you guys what I'm trying to explain. So this, guys, is this. Okay, we don't know the constant. It can be 1. I'm not saying it can't. Maybe 1 or anything, negative number, all real numbers. Okay, so let's take it as k. I don't know. I need to find it out, right? So that's your function, right? So I was given with two zeros. I took care of the constant. I don't know, right? But I have to, because I'm not sure at this point. Because if I don't, and what if there is a constant value? We're gonna end up messing the answer. So now I know this. I need to find the value of k. If you think I'm given it one point already, right? The vertex, it's a point on the graph. So let's substitute. So instead of f, the function, I write -2 is equal to k. I don't know k. X is 3, and then x is 3 again. Okay, I'm not expanding it. Why should I? Why should I waste my time? And I can just find it like this. So, which gives me -2 is equal to k times. So this is basically 2 times -2, -4. Okay. -2 by -4 is divided by -4 is 1 by half. See, it was all about taking a deep breath, thinking about something else, as long as it makes sense. Let me erase this now, guys. Now, I know that the function is okay, so we ended up finding the constant value. Now, by this we know that this is going to be a happy face. Why? Let's expand it really quick. Although we don't need to, just to show you guys. Okay? So this thing is going to be half x squared minus 3x plus 5 by 2. Okay, this is what you will get when you expand this. You see this half is a positive, means it's a happy face. We found that out already. What we need to find out is the y-intercept. So you can insert the value of x as 0 in either this form does not matter. Okay, why? Because at the y-intercept point the value of x is 0. Let's say if I want to find f of 0. Okay, let me just plug it in here. So here's your y-intercept. Okay, let me make a red box. Okay, we answered the question. Let me just show you graphically before I leave. So this is going to be somewhat like this. We know the vertex is 3 and -2, right? This is 1, this is 5. Where's 5 by 2? 5 by 2 is like 2.5. So this graph is somewhat like this. That's your vertex. Hey guys, it's not to scale, so I'm just showing you a rough sketch, okay? Well, so this was our today's SAT question, and whoever out there is giving the SAT, I believe in you guys. You can do this. Thank you so much, guys. Let me have my coffee now.